Hello, my name is Dan Hare. I'm an inventor and I have pump assembly I'd like to show the industry and who's ever interested in trying to market it. It's called a P.A.W.S. It's a pressure altitude water system. Okay, this P.A.W.S. was originally designed around a contest for wave power through the United States Department of Energy. I was unable to get it into the contest, but I thought I'd finish the project and see how it worked. Well, after building it, I realized it worked and had some promise for not just alternative powers, but grid power, wave, solar, like a paddle wheel would make this thing work. I'm going to try to explain the pump and the two designs I have on the wall here, and eventually show you the prototype A pump design that I put together. What I have here is A pump with a P.A.W.S. assembly and a B pump with a P.A.W.S. assembly. The A pump is basically a displacement pump. The weight will displace the water, and because of the way this one's designed, it's a better vacuum pump than it is a pressure pump. The way this one's designed, with the weight of the water and the design of the ram and multiple heads, reservoirs and pumps, it'd be a better pressure pump. This is a hydraulic pump. I'm using a 3,000 pound Parker pump. This assembly here is called a repaw. It puts these two rollers back together over the top of this ball on the end of the hydraulic ram. This black assembly and blue assembly are the contact points for the connection rods going to the piston, and the contact points between the pressure of the hydraulics to the transfer of the weight to this plate which holds the piston. These two contact points on the rollers on the top will contact the top of the pump and push apart and allow the piston to fall through the middle of this assembly and displace the water. When you see the hydraulics work, this pressure put on these two rollers has a locking ear up on top here. That locking ear puts these pair of scissors together, locking them in place while the pressure is being applied to the plate. The same assembly would work over here as well. This piston here, this water tank, just a split view of what would be happening on the real assembly. Let's take a look at the controls. Okay, what we have here is a little stand with control switching, okay, a hydraulic pump, and a 12-volt battery. 12-volt battery runs this rig, and what you have is a magnetic switch for the hydraulic flow from the bottom to the top. That switch will direct it. Then there's 4 micro switches that and tell this switching unit which way to go and when to go. There's one on the top, 2 on the side, and 1 on the deck that shows where the piston's located. In order for this to do a complete cycle, from hydraulics up to hydraulics down to piston up to piston down. These are the components that make up the P.A.W.S. assembly. Tank of water, through a shut-off valve, through a check valve, into the tank with the piston, out of the tank with the piston, through another check valve, and out into the street. This is the P.A.W.S. assembly. This is the repaw, and those buttons on the top are the depaw. This hook right here is the reason why the balls don't just flip all the way. When the pressure of the hydraulics hit these two rollers right here, it will transfer the load to this plate via these arms. Okay, that ear up there will lock together and hold the weight as it's being pushed up. I'm going to bring this up a little bit and show you what I'm talking about. Right now, this 300-pound piston and this assembly is on these two rollers, transferring the weight to this plate via these arms. This is the repaw assembly in the bottom, and this paw has got those hooks centering the whole load. So the whole load is balancing from the rods to the piston off those four contact balls of the balls. When this goes up all the way, it'll depaw and come back down. Depaws, goes back down, reseats. The arms will come down. These are just scissors in here. I'll hit the arms, put them back together, and it'll go up for another stroke. The next section I'll be talking about will be the flow path for the pump itself. We're going to run this, and what's going to happen is this hydraulic cylinder, which is the 3,000-pound Parker, is going to pick this assembly up, contact the balls, depaw up here, the piston is going to come down, it's going to discharge the water outside. Okay, turn it on. Going up, depaw is right there, water comes out over there, this is coming back down, the relays are picked up, and this one hits this contact, it'll repaw and go back up. And that's going back up for the second stroke, goes up, hits, contact out, ball goes back down, pump is pumping the water. Thank you for watching the video in the P.A.W.S. assembly. In the time I've taken to build it, it's been quite an adventure. Thank you very much. If you'd like more information on the P.A.W.S. assembly, via email, I'll be available for questions.